Hi, this is Tom Reardon, math teacher from Ohio. This video is one of several videos showing how to use the TI-inspired dynamic geometry application to help students understand and discover geometric properties by investigation and exploration. This bit.ly website here will show you how to get more information. Please pause as needed. As you can see, this page is very, very complex. It is made up of 3 panes. This pane right here is a list and spreadsheet. This is a geometry, and this is a graph, and they are all connected. This is a radius and its corresponding circumference, same radius and circumference, but rounded to 2 decimal places. And this is the point that's generated by this ordered pair right here. So students are asked to click in the geometry pane and then pull the point to make the circle bigger, the end point of the radius. So I'm going to grab and pull that point slowly, pull it back a little bit there, and you can see what was happening here was as this got bigger, the radius and circumference changed. This automatically captured the data into the list, and once it's in the list, it could plot it as a statistics plot. Our job is to find the equation that models that data right there. So think about it, even pause if you need to. So you can see this is a linear equation. I'm going to click here, and then I'm going to press the tab button on the calculator, and that will get the function drop-down menu. And I'm going to go with maybe a line y equals 2x, see how that goes. And when I graph it, I can see my slope is way too small. So I could try another one and keep playing around. Or one thing on Inspire is you can actually rotate the line and the equation will change along with it. And you can see that about 6.2x seems to be about right. But students should be able to figure out the exact equation of that line. And again, please pause if you need to. But since this is a circumference, and circumference is 2 pi r, then the equation should be 2 pi x. So again, what I'm going to do is tab and go up to F1 and edit F1 so that it's 2 pi x, not 6.19. So 2 and then the pi key x, and this will now be a perfect fit. And again, we don't want to even use 2 times 3.14 or 6.28x. That's an approximation. This one is exact. Please pause as needed. By the way, notice we just made a big connection between the data and an equation and brought back the circumference of a circle formula and showed why that works. So the next page also looks very complicated, but very similar to the one we just did. This is going to capture radius and its corresponding area and then plot it. So I'll click here like I did before and grab the endpoint of the radius and slowly pull it away. And then I'll pull it back to get some points closer there at the bottom. And you can see this is not a line. This is more of a parabola. So again, you would want to come up with the equation that models this data. So please pause as needed. I'm going to go ahead and try x squared, the traditional parabola, y equals x squared. And I can see that this coefficient of x squared needs to be much larger for this to be narrower. So again, I can kind of grab this and pull it around. And it looks like it's going to be about 3.19x squared, something like that. And it's at this point that many of you probably figured out what it should be. So again, I will go ahead and change that. And the area formula for a circle is pi r squared, but in this case it's going to be pi x squared. And again, we want to use pi and not 3.14. Perfect. Please notice that when we did area, the area this surface was covered in, and when we did the circumference, it was not. So we're trying to teach wherever we can here. And so this is a huge connection between algebra and geometry using data collection and math modeling. Please go to this bit.ly website and click on the link for the 90-day free trial so that you can do this activity and any of these activities and over 1,000 activities at the Math Inspired website. Please contact me with questions and enjoy.